Bismillahirrahmanirrahim. Quote of the day: day by day, what you do is what you become. My topic of presentation is hypothesis testing for proportions. I'm Dr. Mehreen Asir, and I'm doing this presentation under supervision of Professor Saira Afzal. Learning outline. In this presentation, I'm going to discuss what is proportions, hypothesis steps for proportions, z-test for proportions, examples of z-test, and chi-square test for proportions. Learning outcome. At the end of the presentation, participants will be able to describe steps of hypothesis testing for proportions. Now, what is proportion? Proportion is a ratio which indicates relation of magnitude of part to the whole. And in proportion, numerator is always included in denominator, and it is usually expressed as percentage. For example, the proportion of students in class who have opted for English as compulsory subject. Suppose there are 15 students who have opted, and out of total 30 students. So this is a proportion. Now, what is hypothesis? Hypothesis is any statement which can be tested. It is a proposed explanation of any phenomena of interest. Now, hypothesis testing for proportions, there can be a situation when we can test for a single population proportion. We take a sample and compare it with the reference values, known reference values. So this is hypothesis testing for a single population proportion. And second scenario, we can take two samples and we can check the difference between two population proportions by using z-test for proportions. Now, this is a basic outline of the steps of hypothesis. Number one is we state the hypothesis. Both null and alternate hypotheses are stated. And then we decide the significance level, which is alpha. And then we compute the test statistic, which in this case is z-test for proportions. And then we calculate the critical, we compute the critical value. And lastly, we state the conclusion. Now we are going to discuss these steps one by one. Before going into steps, let's it's a quick review of assumptions of the z-test for proportions. The sample size should be large, more than 30, and variances and of the population should be known. We can only apply a z-test when the variances are known and random sampling is done for collecting the sample. Now the steps of hypothesis. Step number one is state the hypothesis. We state both the null and the alternate hypothesis. The example of null hypothesis can be effect of a drug A on breast cancer versus effect of drug B on breast cancer. There is no difference in effect of drug A and drug B in treating breast cancer. An alternative hypothesis can be there is a difference in the effect of a drug A and drug B in treating the breast cancer. After stating the hypothesis, the next step is decide a significance level. The significance level is usually taken as 0.05, but it can be 0.01. And 0.1 is also used, but it is not used in medical research. Alpha is the significance level, which is the probability that you will make the mistake of rejecting the null hypothesis when in fact it is true. We determine the critical region. Usually it is 0.05, but can be 0.01 or any other value. So this is a normal curve which is showing the area under the curve. Now there's a concept in two-sided hypothesis. The area between the curve in light blue is 95% when we take 0.05 significance, and at both side of tails, when we divide 0.05 by 2, it becomes 0.025. So area on right side is 0.025 and area on left side is 0.025. Whereas when we have one-tailed hypothesis, that is one-tailed. So the area over here is 0.05. So at one side of the tail, the area becomes 0.05, but in case of two-sided hypothesis, we divide the 0.05 between both the tails. Next step is to determine the test statistic. These are the two formulas which are used for z-test for proportion. In the formula number 1, this is the formula for a single population proportion, in which the p hat stands for the sample proportion minus the population proportion p naught, divided by a square root under root of p naught, which is the population proportion 1 minus p or q, divided by n, which is the sample size. Whereas the formula for a two population proportion is p1 hat, which is the proportion of sample 1, and p2 hat is proportion of sample 2, and then we have pool proportion from both the sample, which is p1 minus p divided by n1 plus n2. We are going to discuss these formulas in more detail when we do example. Now step 3 is to determine the critical value. Critical value can be determined by z-table calculator, and it depends on whether the hypothesis is one-tailed or two-tailed. As already discussed, if the hypothesis is one-tailed, then the value of alpha is 0.05 on one side. But if the hypothesis is two-tailed, then the value is alpha by 2. Now, for looking at the z-table, we find the value of this portion from 0 to t alpha over 2. So in this case, we can see that 50% of population is at the right side. And when we subtract alpha by 2, which is 0.025, it becomes 0. Then we look at the table, it becomes 0.475. So we find that value in the table, and this is a z table. On the right side, there is the first number and the first decimal, and on the second side, there is the second decimal. So we find the value of z by the area on the right side, and so we can see that 0.475 is here. So the significant z-test critical value is 1.96. We take 1 from 9 from here and 0.06, so the total becomes 1.96, which is the value being used. Last step is to state the conclusion. If the test statistics fall in the critical region, we reject the null hypothesis, and if the test statistic doesn't fall in the critical region, we accept the null hypothesis. Now, this is an example hypothesis testing of a single population proportion. The scenario is the proportion of malnourished children in rural community is 70%. So this is the population reference value. A researcher believes that the value is not true. He conducts a survey. So the researcher believes that the value is not true. So he's not saying that it is either more or less. So this is a two-tailed hypothesis. He conducts a survey on 200 children and found that 130 were malnourished. At a 95% confidence level, is there enough evidence to reject the null hypothesis? Now, the steps. Step 1 is that we state the null hypothesis that the population proportion having malnutrition, malnourished children is 0.70. An alternate hypothesis is that it is not 0.70. Now the p hat, which is the population proportion, is so the have taken 130 children, 130 out of 200 children, so it becomes 0.65. Then step 2 is we state the alpha value. They have taken 95% confidence interval, so the alpha value is 0.05. So it is a two-tailed test. On one side, the area is 0.025, and after taking this area, we determine the critical value of 1.96. So we can take the critical value of 1.96. Now, step 4 is we compute the test statistic. As already discussed, the formula of a single population proportion of Z is P hat, which is the sample proportion minus population proportion. So the sample proportion in this case was 0.65 because 130 out of 200 children had malnutrition, minus 0.7 was the population proportion, divided by square root of 0.7 multiplied by 0.3 because it is 1 minus p naught. So 0.7 1 minus 0.7 is 0.3 divided by the sample size, which was 200. So the Z value comes to be minus 1.45. So then we can draw the normal distribution curve. Now the Z value is minus 1.25. Now our critical value was minus 1.96 and minus plus 1.96. So we cannot reject the null hypothesis. Now this is another example testing with two proportions. The scenario is in a nursing home study mentioned in today, the researchers found that 12 out of 34 small nursing homes had resident vaccination rate of less than 80%, while 17 out of 24 large nursing home had a vaccination rate of less than 80%. At a significance level of 0.05, the test claimed that there is no difference in the proportion of small and large nursing homes with resident vaccination rate of less than 80%. So this is a scenario in which we have two proportions. P1 hat is the x1 divided by n1, and P2 hat is x2 divided by n2. Then we get the pooled proportions of both the samples by adding the numerator and denominators. And after that, we can state the hypothesis, null hypothesis, and alternate hypothesis. We determine critical value as alpha is 0.05, critical values are plus 1.96 and minus 1.96. And then we compute the test statistics. Now Z is, the formula of Z is P1 hat minus P2 hat minus P1 minus P2 under root of PQ 1 divided by N1 plus 1 divided by N2. So we assume that P1 is equals to P2, so this value becomes 0. And when we compute the rest of the values, it is minus 2.7. So minus 2.7 is outside is in the critical region. Minus 2.7 is here. So our critical value was minus 1.96 and plus 1.96. So we will reject the null hypothesis. Now, this is the difference between Z-test for proportions and chi-square test. We use Z-test for comparing qualitative data between two groups, only used for large sample sizes when there are more than 30 in each group. Standard error of difference of proportion is calculated by the formula, and it is important that the variances of the sample should be known. In chi-square test, it is also used for the qualitative data. It has advantage over Z-test that it can be applied on smaller sample sizes and when variances are not known. The prerequisites of the chi-square test are the sample should be random and none of the observed values should be 0, and there should be adequate cell size. Now coming to the hypothesis testing steps of chi-square for proportions. Let's discuss the assumptions of the chi-square. The area under the chi-square is 1, as and there is continuous distribution, and x2 value is always positive. Now the chi-square value is always positive because it is a square. Even when negative values are there, after squaring them we get a positive value. As it is always positive, so it is skewed to the right. We can see the tail of this purple line, so it is skewed to the right. And when the degree of freedom increases, the chi-square starts looking like a normal curve. So this is a picture which is showing when the degree of freedom is 3 in purple line. When it becomes 4, it is in dotted red line. And when the degree of freedom is 8, it is shown in the dotted blue line. So it starts looking like a normal distribution curve when the degree of freedom increases. Now the steps of chi-square are the same. We will state the hypothesis, both null and the alternate hypothesis, and then we will find the critical value. And this test is always right-tailed. Now critical value is calculated from chi-square table. And then we find the test value. Now the formula of test value is observed minus expected square divided by expected. And then we make the decision on the basis of the result. This is chi-square distribution, and this is a table of chi-square. Now on the x-axis they have taken the level of significance. It can be 0.05, 0.01 according to your hypothesis, or you determine the level of significance. And on the y-axis we have degree of freedom. So we calculate degree of freedom of chi-square by row minus 1, column minus 1, and then we take the critical value. Suppose if the degree of freedom is 8 and we have selected level of significance 0.05, the critical value will be 15.507. So this is an example of a chi-square test. A researcher read that firearm related deaths for people aged 1 to 18 were distributed as follow. 74% were accidental, 16% were homicides, and 10% were suicides. In her district there were 68 deaths, and 27 were homicides, 5 were suicides. At significance level they have taken 0.10, which is 10%. Test the claim that the percentages are equal. Now the step 1 is they will state both the null hypothesis and the alternate hypothesis. Then we find the critical value. Since alpha is 0.1, the degree of freedom in this case is 3 minus 1 is equals to 2. So after looking at the critical value, we find it to be 4.605. Then we compute the test value. The formula is chi-square is equal to observed minus expected square divided by expected. So the value comes to be 10.549. So this value is more than the critical value, which was the 4.605. So we will reject the null hypothesis. Now it's time for the MCQs. The probability that you will make the mistake of rejecting the null hypothesis when in fact it is true is called as
Alpha error.
Answer is alpha error.
Alpha error.
In alpha error, we can make mistake of rejecting the null hypothesis when it is true. A number of distinctions in a class are 2%. A researcher claims that distinctions are more than 2%. Which of the following is the most appropriate option?
Right-tailed hypothesis.
Right-tailed test B.
Yes, it is a right-tailed hypothesis. As the number of distinctions are, the reference value is 2%, and a researcher is believing, saying that the distinctions are more than 2%, so it is a right-tailed hypothesis. A researcher wants to compare number of stage 1 breast cancer out of total breast cancer in hospital 1 with the number of stage 1 breast cancer out of the total breast cancer in hospital 2. The most appropriate test will be
B. Z test.
Yes, the correct answer is Z test for proportions, as in this scenario, they are taking proportions and the rest of the options are for a mean, comparing mean, not for proportion. A researcher wants to compare two proportions using chi-square test. Which of the following is not true about chi-square distribution?
D.
Yes, the correct answer is D. The area under a chi-square curve is 1. It is always skewed to the right, and when the degree of freedom increases and the sample size increases, it starts looking like a normal distribution curve, but it can never be skewed to the left. It is always skewed to right. A researcher compared percentage of obesity of school children with WHO reference percentage of obesity in school children. Which of the following tests will be most appropriately used?
B.
No, the correct answer is D test for single proportion. So the researcher is taking one proportion from the school and he's comparing it with the reference percentage. So it is a Z test for single proportion. A researcher wants to compare two proportions. He selects significance level of 0.01. Alpha 0.01 means that
A.
yes, the correct answer is A. Alpha 0.01 means that there is 1% probability that you will make a mistake of rejecting the null hypothesis when in fact it is true. The proportion of malnourished children in a rural community is 70%. A researcher believes the value is not true. He conducts a survey of 200 children and found that 130 were malnourished. Calculate the Z value.
C.
In this scenario, we will
C.
calculate the Z value by a Z formula of one proportion with Z hat minus population proportion divided by square root of P naught 1 minus P naught divided by N. So after putting the values, we get minus 1.54. So C is the correct answer. A researcher did study on proportion of smokers in an office. The Z test for proportion came out to be minus 1.29 at 95% confidence level and alpha 0.05. The critical value is plus minus 1.96. What should be done?
B.
B.
Reject the null.
Uh,
A.
Yes, the
Except
correct
null
answer is A.
hypothesis.
Because when we draw area under curve, when there is plus 1.96 and minus 1.96, the value 1.29 is between both these values. So we will accept the null hypothesis. Calculate degree of freedom of chi-square table given in the figure. The degree of freedom of chi-square is calculated by row minus 1 multiplied by column minus 1. The correct answer is A, row minus 1 and column minus 1. When we multiply 2 minus 1, multiply by 2 minus 1, it becomes 1. Calculate chi-square value. Observed value is 4 and expected value is 6.
D.
Yes, the correct answer is D. Chi-square value is equal to observed minus expected square divided by expected. So after, as our observed value was 4 and expected was 6, after calculation, the correct answer is 0.06. This is the key of my MCQs. These are the references, and thank you.
Thank you very much. Wonderful presentation, Dr. Mehreen. I am really glad to see the MCQs because you have made very nice and wonderful MCQs, and the difficulty level was easy, and gradually you progress towards the difficult level. So whenever we are making the MCQs, we always grade them as easy, medium, and hard. So I have seen that your MCQs have progressively become harder and harder till the end of the presentation. So it is the wonderful progression from easy to harder MCQs. The second important thing is, what are the assumptions for applying a chi-square test? Because we know that the chi-square test is the most frequent test that is being applied in biostatistics, especially in medical literature. So what are the assumptions to apply chi-square test?
Ma'am, chi-square test is used for comparing proportions. So the assumptions are that there should be random sampling, and
Actually, the chi-square test is also known as decorticate test. Why decorticate test? Because very less assumptions are there to fulfill. So even without thinking, it can be applied on certain data, and usually it comes out with a very significant result and with a conclusive finding. So that is why it is called decorticate test. The most important thing in chi-square is that we should know that it can be applied on parametric test as well as non-parametric. It can have the random distribution as well as non-random distribution. It can follow the normal curve as well as it can have the other distributions like Poisson, etc. And the chi-square can still be applied. So the chi-square test, as you have shown, that the critical value, it is the most important part that has to be calculated, and it can be calculated in various forms. Some of the researchers, they argue that chi-square is a weak test. It is not as strong as the tests like t-test and z-test. However, there are certain situations where its strength even matches with the other tests. So these are my comments about chi-square test. If anybody has any question or any comment, you are most welcome to tell us, please. Thank you very much. See you next time, inshallah. Allah Hafiz.